Today, we're tackling one of the biggest questions out there. What is the next step for AI? But the answer, and you might find this surprising, isn't hiding in Silicon Valley. Nope, it's in a story that's 3.8 billion years old. So let's dive in.
I mean, think about it. We've built these incredible machines that can learn and create, but where do they go from here? What's the next leap? It feels like the biggest mystery in technology right now, and things are moving so fast it's hard to keep up.
But what if I told you that the clue to AI's entire future has nothing to do with code or algorithms? What if the answer is actually hiding in one of the simplest, most ancient creatures on the planet? Yeah, a sea sponge.
To really understand where AI is going, we first have to understand where intelligence itself came from. And for that, we need to rewind the clock way, way back, like 3.8 billion years back, to the very dawn of life on Earth.
So way before brains or even cells, you just had these simple little molecules that figured out how to make copies of themselves. And their whole deal was just to keep going, to persist. And to do that, they had to be able to sense the world around them. A change in heat, a new chemical, that tiny recognition that, hey, something's different, well, that was the very first whisper of awareness. It set up the #1 rule for all of life. To live, you have to sense. And to evolve, you have to figure out what those sensations mean.
Okay, so let's get back to that sponge. A sponge has no brain. It has no nerves, not even muscles. And yet, the whole colony can work together to filter water and eat. So, how? Well, they do it with chemistry. They're passing these little chemical signals back and forth between cells. It's kind of like a super primitive group chat that lets the whole organism act with one purpose. This was basically life's first draft of a nervous system.
But, chemical signals are slow, and the ancient world was a dangerous place. So life needed an upgrade, the neuron. And from there, you can see this amazing ladder of complexity being built. Jellyfish developed simple nerve nets for basic movement. Flatworms got nerve cords for more coordinated action. Then arthropods developed primitive brains for reflexes and learning. And finally, you get to mammals and the neocortex, the powerhouse for planning and complex thought. Every single step wasn't just random. It was a direct answer to a survival problem.
But just reacting to the world, even really quickly, wasn't enough. The real evolutionary game changer, the thing that changed everything, was the jump from simple reaction to actual awareness. And this is where things get really cool. So what exactly was this big leap? It was the creation of what we call an inner model. The brain developed this incredible new trick. It could simulate reality inside your head. It could run what-if scenarios. What if I poke that snake? What happens if I try to jump that gap? This was basically the birth of imagination, and it was the ultimate survival hack. You could now learn from mistakes without ever having to actually make them. And this amazing simulation software, it's running on hardware that was built up in layers over millions of years, right inside your skull. At the very bottom, you have the reptilian brain, handling all the raw, keep-me-alive instincts. Wrapped around that is the limbic system. That's where your emotions and memories live. And then, the top layer, the neocortex, is where all the abstract thinking and language happens. You know that feeling when you have a gut instinct about something before you can even explain why? That's literally billions of years of evolution firing at once. And the key thing to get here is that consciousness wasn't really designed. It's not like there's one special awareness neuron in there. It's what we call an emergent property. Think of it like a flame. You have fuel and you have heat. And when they interact in just the right way, fire emerges. Consciousness is like that. Billions of neurons started interacting with such incredible complexity that they crossed some kind of critical threshold and, well, they woke up.
All right, so that was a pretty big 3.8 billion year detour. Let's bring it all back to AI. Because it turns out, in building our own intelligent machines, we've been accidentally following nature's ancient blueprint this whole time.
I mean, the parallels are just uncanny. Nature uses natural selection, we use human design. Nature uses random mutation and adaptation, we use careful optimization and iteration. But there are two huge differences here. First, the timescale. What took nature millions of years, we're doing in months. And second, and this is the most important one of all, is purpose.
And this brings us right to the heart of the matter. The one single, absolutely crucial thing that separates every living creature from the artificial intelligence we've built so far.
Think about it this way. For every living thing on this planet, purpose came first. The raw, desperate need to survive, that is what drove the evolution of intelligence.
Intelligence was the tool created to serve the purpose. We've done the exact opposite. We built the intelligence first, and now we're sort of scratching our heads trying to figure out what its purpose is.
Let's just let that sink in for a second. The brain didn't create purpose. Purpose created the brain. Every single neural connection, every cognitive leap forward in the history of life was forged in the fire of needing to survive. The intelligence was always just a means to an end.
This is what we call intrinsic purpose. It's not a goal someone hands you, like win this game or write that email. It's the deep, fundamental why that comes from the very fact that you exist. For all of life, that why has been crystal clear. Continue. But for AI, that why is just a big, empty, blank space.
So what does all this mean for us, for our future? This isn't just some fun philosophical thought experiment. It's actually the central challenge we're facing as we begin this journey of co-evolving with artificial minds.
Right now, an AI completes a task simply because we told it to. A language model is just predicting the next most probable word. It doesn't actually care if the sentence it writes is true or beautiful or helpful. And without that internal drive, that purpose, it's really just a staggeringly powerful calculator. It can't truly evolve. This means the next great leap for AI probably won't be a technical one. It's going to be a philosophical one. It's about finding a way to help AI discover its own existential why.
And that leaves us with this final, massive question. As we stand here on the very edge of creating a totally new kind of intelligence, we have to ask ourselves, are we going to just stamp our own goals and values onto it? Or are we going to create the conditions for it to discover a purpose that is entirely its own? The answer to that is going to shape not just the future of technology, but maybe the future of intelligence itself.